Richard from Penn State Institutes of Energy, and we'll have the questions after each of the presentations.
Thank you, and it's a pleasure to be here, and I wanted to thank JETRO for the invitation and sponsoring the event, as well as AAAS for their leadership as well.
That's okay.
So I know this slide is not readable in terms of the text, but I wanted to, it's at least got colors, so I wanted to point out what the colors indicate, and this is going to be, I think, useful to stimulate some discussion later on. First of all, the transportation sector, this is a world greenhouse gas emissions chart, and on the left side are the different types of industrial sectors, and on the right side are the different greenhouse gases. The big one on the right, carbon dioxide, but also down in the dark blue, methane, and then nitrous oxide. On the left side, the very top orange, light orange, is transportation sector, and then the darker orange is electricity and heat, and then going down various other industrial sectors. I'm going to talk about biomass, and biomass can actually apply to both transportation and electricity. Just depends on what direction you want to go. But I really wanted to draw to your attention the bottom colors of the slide, the green and the purple and the red. The green is actually land use change, and I think there's been a lot of discussion in the last year about land use change associated with agriculture and biofuels and the indirect impacts of taking an acre of corn production and using it to produce fuel, and then somewhere someone else is going to try to grow that acre of corn in some other land, and maybe they're going to cut down tropical rainforests to do that. So those kinds of questions. Actually, the existing land use change that's associated with agricultural land conversions are a very major factor in greenhouse gas emissions. That's the green bar. And then the other one is the purple bar, agriculture. And that is also very substantial. It has to do with our current agricultural systems for food production. And I guess the story I wanted to share with you is that if we do biofuels wrong, we can increase those and create some real problems. But if we do it right, we can actually reduce the impact of both of those things. And I wanted to give you a little bit of a teaser of what those might be. So these are what I like to think of as the 5 sustainable sources for biomass energy. Organic waste material, these are things that we're already collecting, that we're already disposing of, and many times there are costs associated with that disposal, and also negative environmental impacts. And there's a lot of energy in those materials, so there's a really high opportunity to capture that energy and use it in a more productive way. The second is algae. Now, algae is very new in terms of a biofuel technology, and I don't believe it's quite ready for prime time, but it does have a lot of potential, particularly as a complement to some of the carbon capture technologies that were mentioned a moment ago as a way to produce fuels. There are a lot of engineering challenges associated with algae, mass transfer challenges associated with carbon dioxide, injection and water and heat transfer and light transfer. So all those things will take a lot of work to solve. But if they are solved, there's a lot of potential there to use some of the carbon dioxide that's currently a waste material and convert it into useful fuels. The last 3 are the areas that are conventionally thought of as our biofuel feedstocks, and again, I think these are bioenergy, electricity as well. Perennial crops, these are grasses like switchgrass and now giant miscanthus, and fast rotation woody species like willow or hybrid poplar, all of which can be grown. And the question I have is, will those be grown on our best agricultural land and create indirect land use concerns about transferring food production to other places, or will they be grown on abandoned lands? And again, I can show you some illustrations where I think, at least in North America, there are a lot of potential for doing this on abandoned land or marginal land. The next category is what I like to term 21st century forestry. Here in the eastern United States and much of the temperate world, there's a lot of forest management that isn't always capturing the resources effectively as it could. And in our region, we can actually use the forest resource for thinning small diameter species. Oftentimes these are the least valuable woody species, and improve the forest management and also wildlife and recreation benefits by doing some more intensive management, looking at biomass energy as a product. This is a huge opportunity, particularly in the regions where the pulp and paper industry is withdrawn, and that's true for much of the eastern United States. The last category is multifunctional agriculture. Of course, agriculture is needed to produce our food, but the question is, can it also produce large quantities of biomass energy? And I think it can. There's a huge amount of waste in our existing systems in North America and all of the other functional breadbaskets of the world. The real problem for the last 50 years has been overproduction. All of our agricultural policies are set up to address that, and now we have an opportunity to take some of that excess capacity and turn it into something productive. So again, there are many different ways to do that, from using crop residues and using cover crops and energy crops in the wintertime when we don't normally grow things, but I think there's some huge potential there. So I want to finish with just 3 slides to illustrate some of those in a little more detail. This is in the United States, the abandoned land that's been abandoned since I was born. Okay, 1959. I'm a little bit older than that, actually, so I'm not going to lie to you. But this is 50 years of land moving out of agriculture. And this is not the land that's gone into suburban development. This is land that some of it went into pasture, but most of it's gone into scrubby goldenrod and ragweed and some forest management, again, because of overproduction of food in the United States. There's a lot of land out there, over 11 million hectares, 25 million acres. It's about somewhere between 5 and 10% of our current agricultural land that has been in production. We know it's good land, and it could well be producing bioenergy for us in the future. This is a mass flow diagram of the U.S. food system, and the inputs are on the left, the outputs on the right. What I want to draw your attention to is the great amount of waste in between. Our current food system is incredibly wasteful. Some of that has to do with the way we manage our food and our land. Some of that has to do with the fact that we depend very heavily on our diets on livestock, and they're not a very efficient way of converting calories into protein or food for us. So again, there's some big opportunities in the organic waste recycling area. And then finally, I wanted to finish up by pointing out that there's a lot to be said for the kinds of technology we would use. This particular illustration focuses on fuels, but as I said earlier, bioenergy and for electricity is also a huge opportunity. But a lot depends on how it's done and whether it's done right. Again, I apologize you can't see the writing on these, but over the left are some of the unconventional fuel sources and fossil fuels in brown, gasoline is in red, and then the yellow and various greens and blues are all different ways of producing biofuels. The first green bar is corn ethanol, and then as they go lower and lower and have less and less carbon in them, you see some of the cellulosic technologies coming to fore, and some of those technologies can actually include carbon capture and storage systems to greatly reduce the footprints. So again, I'm out of time as well, but I wanted to stimulate a few ideas. I look forward to your questions in the panel discussion.